Hello all, welcome to our channel. So in this video we are going to talk about current mode control and voltage mode control. So what we are going to discuss what's the basic difference between them. So current mode control or the voltage mode control are used in the switching regulators, and they are the control section. They are the mechanisms that are used in control section to generate the required PWM to switch the MOSFET. Okay, so let us talk about them. So if we take any regulator, whether it be buck regulator, boost regulator, ultimately there is a switching element that is present, right? The image you see here, this is a buck regulator, and S is the switching element. So we'll be switching this MOSFET based on which the output will be generated. So every switching regulator that we talk will have an associated PWM input that will be provided to this switching regulator, and this PWM input will be of a constant frequency. So that's what, when we read the switching regulator data sheets, when we say switching frequency, this is what we'll be talking about. Now, when we talk about PWM, right, we mentioned that we'll be providing PWM to the switch. So for a PWM, the important parameters are frequency and duty cycle. So we said the frequency is a constant, and we'll be providing a particular switching frequency to this MOSFET. But to determine the output of this switching regulator, we will be varying the duty cycle. Example, let us assume we have two switching regulators. One is which can generate output from 12 to 5 volts, or our requirement is 12 to 5 volts, and 9 to 5 volts is another switching regulator. So in both these cases, let us assume if we are using the same topology, ultimately in the input, right, we will be changing the duty cycle based on which the output will be generated. And if you have seen our channel, in the previous video we have talked about a boost regulator, and we have shown a simulation where by changing the duty cycle, we have seen how the voltage output of that boost regulator has changed. So just have a look at it. So that's what duty cycle is, very, very important. Now, question is, yes, we said that 12 to 5 volts or 9 to 5 volts regulator, we will have a duty cycle variation at a constant frequency. But the important point is, how do we generate the duty cycle? How internally it gets generated? So that's the major question. That's the entire point of discussion that we are going to have. So this duty cycle that we are talking here is basically determined by a section of this switching regulator called the control loop, which generates the control for this MOSFET. So this control loop, whichever is there, has two different topologies based on the mode in which it is done. One is called constant current mode, and another one is called constant voltage mode. That's what, when you look at any data sheet, we if you see constant voltage mode or constant current mode, this has something to do with the control section that is present within the regulator. Now let us talk what is constant current mode and constant voltage mode. So we have a constant voltage mode. Let us assume this is a switching element. Okay, that's what we were saying, right? We have to switch this element at a particular duty cycle to generate the output. So to generate the switching cycle, we said we'll be providing the PWM input to this switching element, correct? So this PWM at a constant frequency shall be generated from a comparator, which is internal circuit, And to this comparator, there is a fixed ramp input which is generated internally, and that will be provided as a constant to this comparator. And the other section of this comparator will be from a error voltage output of another comparator, where this comparator is commonly seen in linear regulators and all, where we compare the feedback voltage from the output to the reference voltage. So based on this error between the reference voltage and feedback voltage, there will be an error that is generated, and this, based on this error voltage, the duty cycle is going to vary. That's how, based on the output voltage, the comparator input shall be varying, and ultimately the PWM input to the switching error. That's how the output voltage gets stabilized to a particular level. So here the entire involvement is more on the feedback voltage. So the PWM duty cycle is generated based on the feedback voltage. That means the output voltage that is produced by the switch regulator. So this mechanism is, we know, and this is commonly used, and also there is one more mechanism that we said, which is like constant current mode. So constant current mode and constant voltage mode, even though topology wise they use the same, but how the control elements are generated to generate the PWM varies. So here if you see, here also we take the feedback voltage, we take the reference voltage, and the output of this comparator is a difference between reference voltage and feedback voltage, and it will be fed to another comparator. Comparator output is the PWM. But the constant voltage mode, we talked about the ramp input, which is fixed, right? In constant current mode, this ramp is not fixed. This ramp is based on the voltage, the current that is passing through the inductor. So example, if you have seen the buck regulator or boost regulator, there will be inductor that is present, right? So the inductor that is there, and the current that flows through it is sensed and the feedback as a ramp to this comparator, and that generates the bit of, that means there is an additional level of control that is being introduced. So while there are advantages with this mechanism where it brings more control, there are also disadvantages where if the current sensing, or if the current is varying continuously, if the current sensing is not proper, there might be a chance that the output voltage might not be constant. So there are disadvantages and also advantages. The fine control is one advantage, and the stability that we talked is another point where we have to consider here. So that's the major difference if you see the constant voltage mode and the constant current mode. Hope we tried to give you some glimpse of these topics. Please post your questions. Please let us know if you have any other queries on this topic. Please use the comment section to post any other points you know about constant current mode and constant voltage mode, and if you have dealt with these scenarios directly by when you are involved in designing the chips or anything. And please like our video and subscribe to our channel. Thank you.